It's been a little while, but I got sidetracked. I'm back working on this side project where we take LookML content and we want to get it over into Omni. So we're starting to see more clients that want to migrate from Looker into Omni. So we want to be able to get the Looker content in a format that we can ingest into Omni almost as transparently as possible, but without a lot of manual effort. If you have a small amount of content in Looker, it's not that big of a deal probably, but if you have a large amount of content that you want to migrate over, that could be very time consuming and resource intensive. And I don't know if there's anything out there yet to do this, but I'm working on it, and hopefully we'll be able to get a service that people will be able to call to do this. But if you haven't looked at Omni before, this is their website, omni.co, and they're a bunch of guys and gals that left Looker and started another analytics company called Omni. So anyways, all right, where do we start? I was working on explorers, but I kind of shifted over to focusing mostly on view files and things like measures, dimensions, dimension groups, parameters and sets, things like that that we want to get migrated over. So how am I doing that? Right now I'm leveraging mostly a library in Clojure called Instaparse. And let's look it up here real quick. I'm not going to read all the documentation, but if you haven't looked at it, I would recommend giving it a quick boo here, but yeah, it's right here. So essentially it uses a concept of like context-free grammars with I would consider like some peg-like extensions, and the peg-like features or extensions allow you to do things like look ahead, negative lookbacks, and ordered choice. But context-free grammars are used extensively and have a lot of practical applications in technology and computer science. But essentially they're a formal system used to describe the syntax of a language. So that's exactly what we're trying to do. We're trying to describe what LookML looks like, and then we want to get that parsed into a data structure. And then once we can get that into a data structure, then we can map it over to something that is in like an Omni format. So as I mentioned, context-free grammars are used quite extensively, like compiler design, programming language design, natural language processing uses it quite extensively, and then things like document structure validation for things like XML and JSON. Yeah, so as I mentioned, Instaparse probably describe it more of a context-free grammar-based parser generator with peg-inspired extensions. So let's just go ahead and get into it. Don't have to read you the documentation, but take a look at this if you want. It's pretty, it's really powerful. All right, so right now I got a REPL running. This is my my core file. I have a main here that's called. This is basically just to parse the command line arguments. Right now we've given a path to a file, so it can either be a local path or something raw GitHub content. What the document type is right now, we just got view, the output file, whether we want to append to the output file, and whether we want to turn on debugging, which will just spew the stuff out to the screen or to the REPL. So here's our main. And then I have a little comment section here that replicating what the main is so I can play around with it in the REPL. So let's go ahead and take a look at one of these. Well, let's do this first. So I've broken it up into a bunch of different, obviously, namespaces. So right now I have dimensions and measures. I have a logger. There's a parse. There's a shared one for shared functions. And then there's a mapping file here because, things like aggregate types, we need to map the looker type to the Omni type. A lot of times it's the same, except for like maybe something like this. Same with formats here, USD to USD currency 0, things like that. So I'll have like a little data structure here that I can do lookups in and do the mappings pretty quickly. So like here's we're greater than or equal, less than, all that stuff. All right, and let's take a look at one of these files. So let's start off with, let's see, I guess we start off with this one. This is one of the measures. So we want to take this, parse it. There's a bunch of stuff in here that we really don't care about, which is most all this up here. All we care about is, promoting the measure name to the actual measurement, and then we care about the type, the SQL, and these filters. These filters are important. So the way this reads is we've got, and this is a very contrived example that I just threw together, but we essentially got a created date here that's 1 month ago or 3 weeks ago. And then the user status is not disabled. This is the negating part right here, not disabled or active. And the user's age is 25 or 26. So we want to convert that over. So let's go ahead and do that real quick here. I'll walk through this pretty quickly. So we've got looker measures 1 here. This is the file, my log file, the view type. I'm turn on debugging. But the first thing we need to do is read the content in and get it parsed into a parse tree via Instaparse. So we go ahead and read the document in here via slurp, and then I just do I call strip document, which just cleans up, some of the stuff that we don't really need, like lines that begin with a comment, things like that. We just delete all that stuff. We don't really need it. And then we partition that document up into multiple partitions. So there's going to be, this is how we're doing it with this regular expression, the split. And we want to break it up by measure, dimension group, filter, parameter, and set. Now, we could read this all in one go and do it, but as the files get bigger and bigger, it just takes longer and longer for Instaparse to go through all this stuff. So it's probably better just to divide and conquer. So like here's an example of a couple of these bigger ones. So these are 2 of the looker blocks that Looker has out there for, one was for the AWS cost management usage, and one is for the Fivetran stuff. So you can see this one is, you really don't want to have to do this by hand. I don't think so. I'm too lazy for that, but there's probably 200 of these, at least 150 of these that you want to go through and kind of convert over. So let's go back to here. So we have the partitions, and then we go through each one of the partitions, and we want to actually parse it. So I'm using these multi-methods here to create the, I guess I call it a parser dispatch here. So right now, like I said, we only have views, but we can add explorers or whatever. And this is the part where we call the dispatcher with the document, and we look up the document type here, and this will be like view or explore. And then based off of view, it's going to return this this expression right here, which defines what a dimension group, and a measure looks like. So you can look these up and see. It's pretty straightforward stuff, but. So here we're saying we want to look for a measure, a dimension, or a group, or a filter, or a set, or a parameter. And then each one of these have their respective kind of like bodies. Like here's a measure, here's the measurement body, has filters, here's a case statement, here's the dimension group body, things like that. And then you can just kind of build it up here and reuse some of these components here. So it's a combination of regular expressions and kind of defining these literals here, but you really wouldn't want to do this as all as regular expression. It'd be a pain in the ass. All right, so once we get that parsed, then actually have to convert it into kind of the Omni YAML format. And once again, I'm using this multi-methods inside this this dispatch namespace. So if we go look at dispatch here, we can see here is convert to YAML, and right now I've just kind of stubbed out ones for parameters, set, filters, dimension groups. One of the ones I've been working on right now are measures and dimensions. Now Instaparse provides you a nice little transform function that you can call on the various nodes of the tree. You could use, like, I guess, Clojure walk to do this, and zippers and things like that, but I don't know, this is just so much more elegant and easier, and a lot of this functionality is built into Clojure, so you can just kind of leverage that. So this transform function, you know, is one of those deals where here you can see everywhere where there's a key, I want to run the string function on it. Here I want to, you know, run the get value, and then for measures, here's filters. I want to process the filters. So this is going to take those filters from the parsed tree and reformat it into a data structure that is conducive, that we can use inside Omni, that can be consumed. So that's kind of the whole point of these. So measures, I have these. Dimensions have the same thing. Have this case statement one, kind of a special situation there. And then we run these things through a threading macro here to where we, you know, map it to Omni, remove the nulls, and then convert it to a map. So, and then these are just like, here's dimensions. So I have this dimensions namespace here where I have some specific functions that are just for dimensions. So this is like to process the case statements, you know, things like that. And this is what we output the final thing, or the final data structure as. And then we're just using a YAML library to write it out to a file, to a log file. All right, so that's kind of all this stuff here. So let's go ahead and run this. I'm going to go ahead and turn on debug true, so we'll see the output to the REPL hopefully here. So I take this and, oops, make sure I don't, okay, run that. Oops, what did I do? Oh, did I type something wrong here? There we go. All right, so you can see here for this particular measures one, this guy, this is what the actual parse tree looks like, which is kind of some Greek and gobbledygook. I have a little bit of debugging stuff up in here. But this is what we want to get it to. Everything is parsed. And then I can run that transform function on it. So which it did. Let's see if we go back over here. See all this. We actually ran it. Ran right here. So if we go look at the log file, we should see. See a foo. All right, good. All right, so here's the Omni equivalent where we have the SQL, we have the filters. So we had to add the time for duration because it was, you know, 1 month ago or 3 weeks ago. The user status is not disabled or is active. So this is where in that transform filters we write the appropriate Clojure functionality to kind of create a data structure like this with the values that we want. And then here is the aggregate type count distinct, and this is goes through this mapping, this Omni mapping. Most of them are kind of one-to-one, but I guess like here percent of previous, I think that's right. But then we got these things like greater than, equal to, we want to map those to greater than, between, all that stuff. Alrighty, so that is that. And I was just doing this, so this is in measures. Oh no, wait, we are doing, yeah, measures. Let me get rid of this foo thing. Oh no, that was in shared here. I want to get rid of this real quick because I was just farting around here. All right, now let's go ahead and look at another one of these. Let's go dimension case. Let's try this one. Look at dimension case. Now I'm going to go ahead and just run this in, not in the REPL, but I'm going to run it in the terminal here. So I just got to rebuild this jar. Oh, where is that? Here we go. Let's build that. done. Let me just rm tilde this temp. Boo. Okay, and then let's go back here. And all right, let's do this one. And let's go here and do this dimension. Dimension case dot YAML. Append true. Let's just run this. There was only one in there, but let's go take a look at this. You can see here we converted this case when. So there's a couple different ways you can do this. You can just do it inside raw SQL, which a lot of people do, but then also people do it this way, which is probably more the looker way. So with the define a SQL, I just don't do anything with that yet. We don't process it. We just spit out the SQL and map it to the SQL. But if it's a case statement like this, this is how we output it for the Omni stuff. So you can see all the SQL, the label, group label, things like that. Okay. And oh, I think this is more of the same. Oh, I know what this one was. This is a combination where you can see here they have the SQL inside there, and then they also do the case statement. So let's go ahead and run that. Hold on a minute. Gotta delete this file real quick. And let's run this guy. Looker dimension 2. Oops. 2. All right, so then if we look at this, you can see inside here we've got the one where it was defined like this, and then as I mentioned, I'm just kind of doing the SQL one here. We still got to figure that stuff out, see if it's if we want to deal with that. So that's that. Now for these guys, let's go ahead and run it for these big ones, big kahuna guys. This is where I think something like this would be more useful, is if you had, like here's the AWS one. So we run that, you can see there's quite a few of these. Dimensions, measures, and then I think there's a couple sets here. All right, so there's that. And then if we were to look at these guys here, you can see this. We have all the format that we want. We got the aggregate type here is a sum. Then here's the filters. So yeah, so that's kind of what I've been working on. What else is there to cover? There's a lot to cover here, but I won't go into all the crazy details. But it's been fun so far. It is kind of a death by 1,000 cuts because there's all these different ways people do things inside Looker. But I mean, if we can get this even 80% of the way, convert it over like this will be a huge time savers. Then people can just probably run the Omni validator and go fix the problems, but at least they don't have to do this stuff by hand. So that's kind of where I stand right now. Let me know if you got any questions. I'll do another follow-up one as I make more progress. And thanks for tuning in. Bob's your uncle.